reflection of light. So we've all done this before, right? We've stood at the wall, nearby wall or something, and we've shouted at the wall, and we get an echo back. Now there are two different kinds when we're talking about sound. So if the reflection of a nearby wall, we get something called reverberation, whereas if you are away from a distant cliff, you actually hear your sound back. That's called the reflection of sound. Now, what about light? So in order to talk about light, I have to talk first about an impulsive wave. So to set up an impulsive wave, you take a string and you take a wall and you hold the string against the wall and you put it tight. Then you move the string up and down. What happens? That string will become an impulse. This is called a reflection. So when it hits the wall, it reflects back. Light also reflects the same way. Incoming wave comes in, hits a reflecting surface, and it becomes an outgoing wave turning back. In this case, the wave fronts are called crests. And we always measure the reflection from the normal to the reflecting surface. This angle is called the angle of incidence, and this angle is called the angle of reflection. Now be very, very careful when you do your labs and stuff. This is the angle that is the angle of incidence, and this is the angle that is the angle of reflection. For a perfectly smooth surface, the angle of incidence has to equal the angle of reflection. Okay? Otherwise it will not work. So the laws of reflections are incident angle equals the reflection angle. So the angle of incidence will always equal the angle of reflection. And the incident ray and the reflected ray always lie in the same plane. And the normal to the surface is where we measure both of them from. The two rays, the incident and the reflected, are on opposite sides of the normal. So the different types of reflections could be these ones, where in this case the barrier is completely straight. Incoming waves will reflect off this barrier and become outgoing waves. The waves that do not hit the barrier will continue to go forward. The other case is spherical. If the waves coming in are spherical, they will be reflected back as spherical waves. So in case of a spherical wave, if the wave source is a completely dot here, then then it hits the barrier. It is almost like that the reflected waves are originating from a virtual image of wave source, and then they will be reflected back, going backwards. So here's another important thing to remember. The direction of the reflected waves originate behind the barrier, and these are called virtual images. We will be dealing with a lot of virtual images in your labs as well as in the future chapters. So what is an advantage of a reflection or a reflecting surface? Well, one of the things is, I don't know if you've ever noticed your dish antennas or something like that, they are always made in a parabolic shape. And the idea is that incoming waves, if they did not have a reflecting barrier like this one here, what that would happen is most of the waves will become lost. But if you have a curved path and you can figure out where these angles are going to be reflected, at that focus point you could put a receiver so that all the waves that are coming in get received there. That's why all the telescopes and stuff, sometimes those big telescopes that you might have seen, are made in a concave shape to get as much light as possible coming from faraway galaxies. So there are two main kind of reflections. One kind is called a specular reflection, which is a reflection from a smooth surface. Reflected rays are parallel to each other, like these ones. So rays coming in, rays going out, or a laser pointer, for example, or like these ones, right? These are called specular refractions. Diffuse refractions are reflections from a rough surface. These reflected rays travel in a variety of directions. So for example, this kind. Diffuse refractions could be, they don't have a particular path, they kind of get diffused all over the place. And that makes the road easy to see at night.